4, 3, 2.
In this segment, we're going to talk about language modeling. What is language modeling? The basic idea is that we want to take a sequence of words so far that we're going to call the context. This is a word that I'm going to keep using to refer to this. So in this case, I've started typing out an email on my phone, and the context is I like to. And we want to predict what word might come next. So I've circled these in green here. C, get, B. This is what my phone keyboard says might be the words that are likely to come next. And these make sense, right? These are all three words that I might decide to write next. And so if I decide I want one of them, I just click it, right? So the idea behind this is to try to help someone out by predicting what they're going to say next. And that's fundamentally not possible, right? We can't read their mind. We don't know what they're going to say, but we could still try to make guesses that are as good as possible. And so this is going to be our goal. From the context, predict what word is going to follow. So I want us to think a little bit about what's involved in this. So if we start with a kind of similar context, I want to blank. So that's where the word that we're going to try to predict next is. There are a lot of words that can come next. I want you to think about a few of them and think about what they have in common. And the other thing I want you to do is try to think of a different context, so not I want to, but some other sequence of words that makes it so that the next word has to be something in specific. Like there can only be one word that follows this sequence of words, or it's very likely that there's one next word that follows. So I'm going to pause here for a second. You can pause the video and do these things, and then we'll talk a little bit about the answers. Okay, so I'll show you some examples that I came up with for this I want to context. So maybe I want to swim, I want to eat, I want to play. We could think about what sentences might follow from each of these different things. So I want to swim, that's fine, that's basically a whole sentence. I want to eat Korean barbecue, or I want to eat lots of cake, or something like that, right? I want to play video games, I want to play tennis. So there's lots of ways that this can continue, and if you think about it, each of these three words might be pretty likely: swim, eat, play. Something like shovel is probably less likely, right? I mean, I could say that I want to shovel snow, but most people don't like shoveling snow, so this somehow doesn't seem as likely to us. That's why I drew it with a thinner arrow here. So this example I think is interesting because this is a grammatical sentence. It makes sense, right? But it's just less likely to show up. It's something that probably your phone shouldn't surface because you're less likely to pick it as an answer. So there are a lot of other contexts like I want to, which can have a lot of things that come after them. So for example, hey blank, that's another example. But I ask you also to try to come up with one where there's only one word that can come next. Here's an example I came up with. The capital of Nebraska is blank. So this is a good test of how well you know your US geography and US state capitals. The correct answer here is Omaha. And so we don't really want to suggest other options, right? I mean, someone might say, a different answer that's wrong, but in general, if we see the sentence, the capital of Nebraska is, probably the next word that we want to predict is Omaha. But this is very challenging to do, and I think this suggests why language modeling is a problem that, again, is not easily solved by just writing down some rules, but we need this more powerful machine learning tool in order to address it. So why are we looking at this problem? Well, I think the predictive text stuff is pretty cool, but it's also the case that language modeling is a tool that powers a lot of the most exciting things that are going on in NLP these days. We're going to come back and talk about this stuff later, but some of the biggest systems that have come out from again, this company OpenAI, as well as how Google search works these days, fundamentally use this kind of language modeling as an ingredient in them. And so by understanding this problem, we're going to be able to understand a little bit more about what these systems are doing. So specifically, what we're going to be looking at is a form of language modeling called n-gram language modeling. An n-gram is just a fancy term for a list of n words. So I like to, that's a 3-gram because there's 3 words in it. I really want to go, that's a 5-gram because there's 5 words in it. So an n-gram language model is going to predict the next word based on the previous n-1 words. So if we have this context, I want to, and we are approaching this with a 2-gram model, a 2-gram model is only going to look at the previous n-1, so 2 minus 1 words. So it's only going to look at one word of the context, which is 2 blank. So I'm going to leave you with a question here, which is supposing we have this context. You wrote down some answers for this before, or you can look back at the ones I wrote. And now we're saying that we're only going to predict the next word based on 2. How does that change the examples that you came up with? Are there new examples that can follow 2 but can't follow I want to? How does this simplification of the problem that we're using affect your answer? I'll let you think about that, and we're going to come back in the next segment.